Good evening, everyone. This is yet another follow-up video about the progress of the AmiCube development. I've spent quite some time dealing with clocks and trying to make improve performance between 68,000 and FPGA chip, in this case Spartan-6. And right now I am somewhere at 38 MHz in turbo mode, after which system becomes kind of unstable, which is definitely not ideal comparing to my Minimic board that can operate up to 60 MHz, although I shouldn't say 60 MHz, that's the upper limit, maybe 50-ish range. So right now I'm at a 40, so 10 MHz is missing. And considering everything now, putting better constraints in the design, I'm thinking that most probably is due to the fact that this is a different die. It's much larger chip, and it's just a path that's producing different timing that needs to be adjusted to get to the same point or even above. I think with the further Verilog development, I'll be able to produce even better results, hopefully. But I'm satisfied with 40-ish megahertz result right now. It's super stable at that clock, and everything seems to be working well. So I won't spend much more time optimizing the path and delays and whatnot, timing stuff, because obviously we are moving to AGA architecture now, and I'm going to replace the entire core before I'm committed to something that's production worthy. I mean, that's definitely kind of solid result that makes me happy. But also, I want to say that I was able to port rather next-gen DCMs that I'm using to PLL, one PLL to rule them all. In fact, I'm using one PLL to generate all the main clocks, and that's phenomenal, I think. New board is on the way. I'm going to do some further adjustments. First of all, these stupid reversed polarity LEDs. I'm looking at Acti-Low now. So I want to reverse that. In fact, I made a stupid mistake. Behind I have inverters, and this should be opposite. But then I actually turned the LEDs the wrong side and the wrong way, which is my signature mistake, and I do that all the freaking time. I don't know why, but either way, new board will have this kind of fixed. It's not a big deal. It's just a minor adjustment in the schematics. And obviously now we're looking at the floppy connected and clicking. I don't know if you can hear it. And not surprising, it works fine. I mean, why wouldn't it? I'm using the same module that I wrote for Spartan 3. I just ported it to Spartan 6, and since clocks are in line and constraints are in place, there's absolutely zero reason not to work. One thing that's kind of hallelujah moment is that obviously I'm not using the transistors for level shifting, and why would I? That's, in first place, that was kind of dumb because I have so many different level shifters here in my collection. So I'm using these parts. These are 3.35 volt level shifters, and they are designed specifically, well, I shouldn't say designed for floppy, but the characteristics of these level shifters, characteristic of these level shifters is perfect for shifting signal for the floppy. They're different than these CBTDs, and they're much newer part, and I may consider using them here as well, because they will do just fine. But for the floppy, looking at the data sheets, these are much better. So that's a great thing. Obviously we can try to load something. Unfortunately right now I don't have a second power cable for floppy, so I'm just going to connect one, and later there will be video showing off the two floppy drive feature, which seriously, it's not, I mean, it's the same thing. It just has one more additional select signal and a little bit, I mean, there is logic already in place to handle the second drive, so it does work. One thing also interesting here, you can see that here it's active low. There is a detection, so I have a little label of the floppy, and now when you connect the cable it will become active low, and that means detects the floppy, the system itself. Although again, I'm going to revert this, so it's going to be off, and then when it detects floppy it's going to be on, of course, as it should be. But again, this is the part of the same signature mistake that I made. Either way, it's connected, it's clicking, and I'm using one of the floppies, BAT. Yep, there you go, and regular stuff. I'm just sorry for the very poor video quality. I'm using my cheap USB to HDMI sampler, but you'll get the picture. I press the mouse button, it's loading stuff. It takes some time. Okay. Right now, I believe I'm running in normal mode. One thing that I mentioned with Spartan-3 with the Mini-Mig is that the module itself was working best on 20, I believe it was 28 megahertz, which is the one of the main clocks in the system. I think most of the components are actually internally working on that clock. When I go to non-turbo mode or above 28 megahertz, then sometimes I have little glitches with some versions of Xcopy program. But I know what it is. It's a timing, and just certain things need to be constrained better. But I mean, that's something that I'm going to polish once everything is in place. I don't want to work on that and get my focus out of AGA and then do it again, all over again once I have AGA. I mean, you know, just I'm trying to be smart about the sequence of the events here. Anyhow, aside from the regular signals here for, I don't know, reading the data, MFM data, this and that, I created this on the other side of the board. I created this discrete logic system of transistors that will flip between ready signals of the first floppy and the second one, depending on the select signal. So depends. I mean, this should be done in Verilog, I guess. I don't know why I did it this way, and I'm not even sure if this is quite necessary to be done like this. But looking at the logic analyzer, I kind of concluded that this might be the case. If it's not, some future iterations will have this done differently. But these signals that you're looking at, they are actually coming from transistors from the behind of the board. Just a little bit of logic there. So what else to say? I mean, it's another milestone. I'm kind of satisfied with where I am right now with the PLLs. It's fine, works just fine. 40 megahertz is more than enough. If I really wanna speed now, I would use PyStorm, not 68,000. So 40 megahertz is decent. In future, hopefully we'll go 60 and maybe even beyond. We'll see how it goes. Because now I have better understanding of what was the problem with the clock in the first place in Mini-Mig. So slowly, as I'm getting more experience with the Verilog, I'm confident that I can push some limits. And then floppy obviously works just fine. Voltage regulation is fine. Quite a few little things to kind of fix. I should make a jumper here for 3.3 volts and 5 volts depending on the clock. Since I'm using now 25 megahertz, I'm just feeding this little part with 5 volts, so you can count at the level of 25 megahertz. I think to replace entirely this subsystem with with a modern part, instead of using crystal and the counter, I can just use modern part to replace all this. So oscillator, so to speak. And what else to say? I mean, that's it so far. I mean, that's a progress. One more thing off the list. Next video that I make will have much more in-depth test of the two floppies, DF0 and DF1. And then, of course, one of the crucial parts of this project is going to be implementing this into Minimig menu, because we want to make sure we can use real floppy or ADF instances, virtual floppy, and then we want to consider using real floppy with ADF file, and that will require perhaps some timing voodoo to put in place, because there is this disk rotation that's in this case real, and in case of ADFs it's kind of emulated, so we need to kind of bridge that gap, or bridge or cross that bridge once we're there. But I think if what I'm saying it makes sense in the first place, from the top of my head, we'll be able to do that as well. And this is going to be ultimate backup machine, because you'll be able to use ADF and then just slap the ADF directly on the real floppy, which for us Amiga people, that's a great thing, having this box that can do that for you easily. And you can enjoy real floppy experience with the floppy sound, or you can just load the games lazily out of SD card if you prefer to do so. So I think I should wrap it up for now. For this video, next one I'll try to do some further tests, and I have one more interesting thing to show you, and that's also coming soon. I was thinking maybe to keep it as a surprise, but there will be more boards coming that I'm designing. I'm making some really high-end stuff that will be able to emulate, or not emulate, but recreate things like PowerPC and high-end systems, and maybe get into the field of making an ultimate machine that can do all sorts of retro systems, and I'm talking beyond what Mister and Mist can do. I don't know if my lamp does the justice, so I'm trying to set up lights so you can see what these are. So what I have here, these are really serious high-end parts. Depending on which part we're looking at, this is just like, you know, an ultimate thing. We can get these parts from China, we can get them new, we can get them repurposed or recycled. Basically they just remove it from a machine that was in use, and then check the part, they rebuild the part and they ship it, or that we can even order in large amounts brand new parts. And we're looking at a totally different category in FPGA parts. So this is first of all generation 7, which means we can use, of course, Vivado, big deal. But the density of this part is just, I mean, bonkers. From the top of my head, I think here we are looking at 300,000 LEs. This is, you know, Kintex part. You'll find this in the aerospace defense boards, electronics, and this is definitely something we're going to play with. Some of the boards I want to design, I'll have ability to add multiple of these chips on the board, and then really sky's the limit. Or go with a kind of cheaper version with one Kintex. And application, of course, goes beyond retro computing, because this is definitely overkill for the retro computing at the moment. But it really depends on the developers, what kind of design they implement for PlayStation 3 in the future and things like that. You'll need parts like this. Then there is Zynq, also the same generation. We are looking at the SoC here. So basically there is a very capable ARM computer on this chip, but also there is a quite large fabric, FPGA fabric here, and this is kind of in the same category as I would say Altera Cyclone 5 from Mister, but just with one important difference. These parts, you can now get really dense parts of Zynq that you can use in the design, and sky's the limit. I think this one is 100,000 LEs and plus very powerful ARM CPU on the die. And then there are things like this. This is Arctic 7. This is above Spartan. So after Spartan goes Altrix, and I mean, this is the platter of I/O. I'm not sure exactly this one has. I'm trying to see how many I/O lines, but it's phenomenally high number. This one I believe is 200,000 LEs, if you can believe it. So going from Spartan 3 that has 8,000 to 200,000 LEs, if I'm looking at this correctly, it's just bonkers. So these parts, we can get them nowadays, and especially if you order a high quantity of these parts and we make some sort of arrangement with AMD here in Canada, I think sky will be the limit. This needs to go to the board that's kind of already tested in terms of I/O and where we're going with I/O, because obviously with where we right now with AmiCube, there will be more changes here, and I'm realizing this music is still running, so sorry for that. Hopefully it won't be too annoying. But I want to say first we'll replace this with a USB, then this will be HDMI, although I would like to keep option for analog output as well, because why not, it's a retro computer. And of course header for MIDI, because many of you guys are asking me for MIDI. This is Amiga nowadays, it's a retro music machine for just creating mods and stuff like that, so we want to have MIDI for sure, aside from the floppy interface. So, and then goes a platter of other things, because now we're talking about really dense I/O and fabric density. Especially if you go with something like this, then I mean, you really, there's no stopping us creating whatever we like. And just imagine one silver Kintex here, it will be very nice. Again, before I even consider that, I need to put everything in place and test and have a reason to go to such a specific density part, which is of course more expensive to source this. Used, not used, or whatever, these are not cheap parts, and something to consider. But definitely within a couple of months we'll have boards running these amazing Zynq parts, and we'll switch everything to Vivado eventually, because really we're hitting the wall with ISC. I mean, there's not even updates available or proper licensing and stuff. So there you go. I hope this video was cool. Again, just to summarize, we have working AmiCube with the floppy disk controller, with stable PLLs now running at 40 MHz, to be more precise, 39. We have tested most of the functionality of original Mini-Mig, and now it's time to kind of start rewriting some of the parts of the design, replacing them with the modern code. So that's happening. All right. So here's another video from the future. This is about 2 days after I started filming, and shortly after I did the initial test with one of the drives, everything seems to be all right. But then after testing a couple of different floppy disk drives, I start noticing certain issues with a couple of things. One of which is, first of all, AmiCube not being able to detect the drive at all, to being unstable in the operation during the read and write. So I was suspecting these level shifters that I'm using, and these are, I mean, pretty good level shifters. I've choose these TXS0108 for a particular reason, and that is that these are optimized for open drain operations and have 4 kilo ohm pull-ups, which seems adequate because that's what we have here with MOSFETs. But I'm now realizing, learning more about these parts, that there is something called one-shot accelerator inside, and these accelerators might misinterpret noise as a valid edge, especially if you have capacitive loads and interference coming from these very long cables. So that's one thing. These edge accelerators are quite useful when you're dealing with modern parts, but in this particular case, when we are playing with old floppy technology, it may interact in a poor way. So that's one thing that I'm kind of suspicious about. The other thing is dynamic pull-up, which is 4 kilo ohm, 40 kilo ohm, depending on the low or high state. And this is, I think, that 40 kilo ohm pull-up when driving low is too weak for reliable operations with the floppy drives in general. And this can lead to slow rise time or just invalid logic levels. So instead of having these dynamic intelligent pull-ups, so I would prefer to have just 4 kilo ohm pull-ups on each side, as it should be. So I think the part itself that I'm using is too intelligent, let's say, or too feature rich for the implementation. And this is just a hypothesis. I didn't test this yet, nor I was looking at the oscilloscope and logic analyzer further, but this is how I feel at the moment. So, and just a feeling based on what I'm reading. But we'll see. I'm going to do further measuring and experiments, so we'll figure out. So what I can do is I can add, of course, external pull-ups. Then I can dampen the accelerators by adding a small resistor in series. And I can totally disable internal pull-up using this pin. I believe it's called OE pin. Now it's pulled high, but if I pull this pin low, the internal pull-ups in the shifter will be disabled. So I think that will produce good results, because there's no really a reason not to work, as I mentioned, and it does with Samsung drives almost perfectly until it doesn't. But I mean, it's a good indicator. Also, interesting thing was this part where floppy will start loading without inserting the floppy, which is again another indicator that there is something with these maybe edge accelerators or just the pull-ups where signal is being detected as moving from low to high or high to low, which is again in line with what I'm reading here about these parts. So if I was implementing this with something that's modern and fast, I probably wouldn't have any issues. But with the old floppy and the fact that the ribbon cables are quite long, there might be all sorts of issues. So what now? Obviously, discrete MOSFETs are just fine. So I may use that as a, why not? It's well tested. But I will still do a couple of experiments in the hope that I may use these or some other level shifters, because it's easier having a couple of parts instead of, assembling something like this, which looks like something from 1965, from Cray supercomputer or something. It's all discrete. But either way, we'll get there. I think it is a process of learning and experimenting with these parts, and even if I choose a different part, that might be as well okay. But before I commit to anything, I just need to make sure I test well. And again, worst case scenario, MOSFETs will do just fine, because they do work well as tested. So that's that for this video. It's been quite a long video and difficult to kind of do the montage and everything. So I hope that it was informative. Stay subscribed and like if you can. I'll have more videos coming. Now we're in the process of moving to AGA core. Super exciting. And at some point we'll put this all together into one package, the floppy, AGA, CPU, and then hopefully within maybe a month or 2 months, the longest period, we'll have AmiCube ready. Thanks for watching and talk to you soon. Bye bye.